Okay, I think we're recording. Thank you for introducing me, Lala. That was very sweet. Yeah, so let me get my PowerPoint set up and we can start from there. Oh, I have to share my screen first. Okay. I'm gonna move my Zoom controls. Okay, yeah, like Lala said, I'm a research instructor at CETA. I work a bit in the consulting center. If you've seen me there, I also work with hematology data often. But yeah, I've been at CETA for a little while and I have become very familiar with several tabling packages. So I'm using this as an opportunity to kind of put it all together and put one big PowerPoint and go from there. So first, I'll go through a quick agenda. I have some definitions to just quick set us up for success, I guess, before I start talking about reproducibility and how it kind of relates to table ones. Then we're going to talk about a little bit like the why table ones, what they are, and like what should be included in table ones. And then I have some examples in an R Markdown, or I guess Quarto document, same thing, about table one packaging, table ONE, like the word one packaging, gtsummary, flextable, Kable, and Kable extra, which are all different packages that you can find and download in R. And then I have a very high level pros and cons table to talk to kind of wrap us up, and then attendance at the very end to enter you into this raffle that I hear with AirPods and things. So yeah. So first I want to start and distinguish and define like what reproducibility is before we get started, and how it plays in with table ones and all of that. So this is a definition that I found from the National Science Foundation on robust research. And I'll read it for you now, but it essentially says the ability of a researcher to duplicate the results of a prior study using the same materials as were used by the original investigator. A second researcher might use the same raw data to build the same analysis files.
Yeah, I'm excited.
Sorry, could you make sure you're muted? Anyways, a second researcher might use the same raw data to build the same analysis files, implement the same statistical analysis. If the same results were not obtained, the discrepancy could be due to differences in processing the data, differences in application, and all these different things. So the reason why I wanted to put this definition in is because it's often used interchangeably with replicability, which they're very different. And I didn't want to continue without kind of exploring the difference between them. And the replicability is essentially the same thing, but you're using new data. So for the purposes of this talk, we're talking about reproducibility and kind of how that relates to statistical analysis and data analysis. So yeah, in the statistics field, I guess the question we want to ask now is how does this play into table ones? But maybe a better question to ask before that is what is a table one and what is included in it? So there's a study called Who's in This Study Anyways, which kind of displays what they think is good information to include in a table one. And if you're anything like me, for the longest time, I actually did not know the phrase table one referred to a relatively specific table that we see in pretty much any publication. I had somewhat naively thought that it was just whatever table investigators had decided to place first. But no, if you haven't had experience with it, it is essentially a snapshot of who is in the study at hand. And I really enjoyed this publication, so if you have a chance, I would maybe glance at it if you're curious. But I'm going to be talking about it a lot in this presentation too. So most importantly, I think table ones give you a really quick glance at who's enrolled in your study, and if you see anything strange or unusual about it, which really kind of relates into this topic of generalizability. And this infographic on the right kind of shows how generalization is kind of broken up into two different concepts, internal validity and external validity. So for example, we can extrapolate to like people with a certain diagnosis if they're not enrolled in our study, and that's something that we can easily see in a table one. Or even from the data analysis side, we can see or have red flags raised if variables are operating incorrectly. For example, if we're taking the mean of birth years, when maybe we really want the number of birthdays that occurred in a certain year, like what does that mean? We can kind of do a little gut check on what types of classes or variables are in and kind of use it to double check ourselves. So the main things to think about in terms of external validity, we're thinking about like its applicability to other patients, other populations, and if we're including any, like all the proper effect modifiers, which these are things you can kind of glance at a table 1 and see kind of your thought process from there. Internal validity, you're kind of thinking about like risk of bias. So the 3 main things there are confounding, selection bias, and measurement error. So confounding, you can think about differences in other causes of the outcome between exposed and unexposed, or selection bias, kind of how you've recruited your cohort and if that would have any impact on your results, or measurement error if there was some sort of issue going on with the data collection. Yeah, so the next thing I have is this image that's included in that same paper, the Hayes and Larson from 2019. And the top part of this here, I'm going to turn my cursor to be a laser so you can see my pointer better. This talks about what information should generally be in columns, what information should generally be in rows, and what should generally be in that each cell. And this, I liked this infographic especially because it talks about each idea and how it relates to external validity and internal validity. So it kind of relates back to how generalizable is your study. So this top row talks about things that should usually be in most table 1s. The bottom half of this talks about things that may or may not be relevant to your research at hand. So this is depending on, if missing data is an issue for you, if you're weighting things, or if you have clustered data, this may be things you think about later on. But again, for the purposes of data week, I'm probably not going to go into this just because it's very analysis specific. And I think the main thing to look at is the top half, where we're looking at including the total column, stratifying by, if it was a case or control or any of these things. Rows, we would generally want to see all of the variables that were included in the model, or maybe even considered to be included in the model, depending on the scenario. And then in each cell, we will see if it's a categorical variable, we'll see a percentage. So if we're thinking like percent men or percent women, or if it's continuous, we'll be looking for either mean or median, and maybe upper quartile or IQR statistics to kind of give us an idea of the distribution of each of these variables. But yeah, this is a good thing to kind of check yourself with, I guess. So the table I have included here is again from that same publication, and this is an example table that they have. And they talk about, they're pointing out things that they think are good things to think about and to include when making a table. So for this particular example, they're talking about stroke cases and controls. So you can see that they have a cases column here and then a controls column here. So the first point that they make up here is they say including a column total for the controls that shows a distribution of characteristics in the source population. So what this does is that we have essentially 2 versions of controls. In this example, we have unexposed and exposed. Having this total column allows us to compare the distribution between cases as well as controls, which can kind of it can show any potential issues that may arise. Like maybe you have an odd distribution in age that changes between the cases and controls, or things like that. So if we, if we're looking at this example, we can see that the distribution between like in the demographics seems to be almost identical. We have 38% males and 37% males in the controls. And then we have 4% 18 to 40, and then 9% 18 to 40, 13 and 14, 69, 73. So it seems to be pretty closely distributed. The second point, you're stratifying by the controls exposure because it shows potential confounding. So in this scenario, they think this exposure variable is also going to impact the distribution between whether or not it's a case or control. So they're kind of accounting for this, I guess, preemptively by including it in a column of their table 1. which they are saying relates back to internal validity. Point 3, this paper I thought was interesting, actually recommends, well, for this recommends no p-values, which I think the main takeaway for this is to include p-values appropriately, because in this case, we know that the cases and controls are going to be different in terms of stroke outcome. So it wouldn't really be that meaningful. So I guess the main takeaway for this is to just kind of be, and I think there's a presentation later this week about basic statistical tests like chi-squared and t-test. So they'll talk more about when to use each test, but just keep in mind and make it be deliberate about what test you're including and when. And then their fourth point is showing variables as collected as continuous and categorical. You don't have to do this, but I thought it was nice to see like a couple different ways to present some variables like age that maybe can be displayed as categorical or can be displayed as linear. So it kind of depends on the topic at hand. I generally will like to keep things continuous if I can, because I feel like it doesn't lump so many people together and kind of gives you a better idea. But sometimes it is beneficial to present both of them because you can get the mean and you can kind of get a better idea of the distribution outside of just the mean and standard deviation, if that may be of interest to you. Point 5, it says to reduce visual clutter, show percentages rounded to the nearest whole number unless more precision is warranted, which in most cases, I would argue precision is usually not warranted. For the purposes of a table 1, we're using this as kind of a very quick glance at who is included in our studies. So we don't really care if there's 11.5% of people that have an education less than 5% or an education less than high school. We really care about the greater distribution, and adding too many percentage points is 1, messy, and 2, kind of displays like potentially a level of precision that like we can't guarantee in the statistics world. So it kind of be deliberate and cautious with how many decimal points you're including, because in an effort to not portray a false sense of precision. Point 6 and 8 are actually pretty similar. This says including selection variables, even if not included in the final analytic model. This allows the distribution to be compared between cases and total controls to make judgments about whether cases reasonably arose from the source of population. So this is just saying they suspected that insurance may have an impact on stroke cases. They're wondering if whether or not, like, for example, if we saw something like maybe like 80% of stroke cases were uninsured, then that may be something you want to pursue. But it seems like that, you know, the distribution of this insurance status is almost identical across the board. So they're including it because it's probably a pretty common follow-up. It's probably going to be a question that is often asked or is considered and thought about when looking at things like this. So they included it anyways, even if they did not include it in their final model. They're just saying that sometimes it's nice to include variables of interest, even if it was not even if you did not end up including it in your model. And then point 8, I'm actually going to skip over point 7 really quickly because I feel like this is pretty closely related to point 6. Showing potential modifiers, e.g. hypertension or other like biologically plausible modifiers, even if it's not included in the final analytical model, can help readers assess the generalizability of findings. So there's kind of 2 pieces to this, and it kind of boils down to the internal validity and external validity of including variables that you think are biologically interesting to kind of allow you to check the internal validity and the external validity of your population. And then going back to point 7, they suggest to show skewed continuous variables as a median rather than mean. And this is because we suspect, or we know that medians are more robust against outliers. So if there's a very big skew, you may consider presenting median in addition to mean, or at least presenting a median because it may be more in line with the story you're trying to tell. Okay, and now I'm going to pop into some R examples, and I think we have some questions in the chat. Is that correct?
No questions, just my announcements.
Okay, I'm going to, oops. Apparently I can't fix it out of this. Oh, there we go. Okay, so I'm going to switch to R. And I am not quite sure if you guys have been exposed to R markdowns, so I'm going to assume that you haven't. R markdowns can work, essentially these grayed out chunks, they call them, can run code, but an R markdown will combine free text like you would put in a Microsoft Word document. You can type paragraphs and all these things. It will combine free text like you would type normally with R code. So this is an R markdown that I'm hoping that if you guys want to, play around with this later, you should be able to download this and kind of mess with it on your own time. But this will allow you to, I try to put some context above, each of these chunks to kind of walk through what I'm talking about, but I can run each of these chunks like this, and it will load them into my environment. So, and you will notice, if you're wondering why my R looks a little bit different, it's because I've swapped my console and my environment. That's just how I like my R setup. So if you're looking at this a little confused, that's why. So first I installed or loaded, I guess I should say, 2 packages, tidyverse, which I'll talk about a little bit later, and then survival. I'm only downloading survival because there's a data set that we'll be using later, so you don't have to worry about this right now. So I have a handful of packages. You can see a little tiny outline on the right. I'm trying to make the font a little bit bigger. The first package I want to talk about is table 1 with the number 1. There's 2 to make things a little bit more confusing for you all. This was it used to be my old favorite package. It was my introductory table 1 package. So it's a little bit nostalgic for me, but we'll talk about pros and cons later. So I'm going to load the package by typing library in table 1. I'm loading boot because it has an example data set. So, and if I'm not sure if you guys know this, but some packages like boot and survival will have toy data sets downloaded in the background. So if you're looking at my environment and thinking like, wow, that's empty, like how am I going to print this this data set with melanoma? It's because it's loaded in the background of loading boot. So this is what the data set looks like. I can scroll to the top. It's got 1, 2, 3, 4, 5, 6, 7 variables: time, status, sex, age, year, thickness, and ulcer. So this is the syntax of table 1. You have this little tilde, and tildes just mean in R, you're going to input an equation. And the syntax for all of these packages are slightly different. So hang with me. But for this particular package, it requests an equation, and then you can put your data set in to run and produce a table. So for this, I'm telling table 1, I want to create a table with these variables. The ones I have listed before this vertical bar are the ones I want in the rows, and the ones I put after the bar is the columns I want to include. This call factor is meaning that so right now you'll notice that sex has a value of either 0 or 1. It's probably going to be read in as numeric. So this is ensuring that we're keeping sex and as levels, because we don't care about taking the mean or median of the sex variable or the status variable. We care about keeping them as separate levels, which is what this factor does, which I can show you. I'll run this for you. You can see what the default looks like. So this table it looks pretty good. Just right off the bat, it's pretty simple, but you'll notice the naming is kind of bad. Like 1, 2, 3 doesn't really mean very much. And you'll notice that the factor does appear in the row names, which is not very pleasing. And then we still have these, the named levels as 0 and 1, which is not very meaningful. So what I'm going to do is I'm going to copy this data set locally so I can make changes to it. And we can use this factor function to rename the variables and fix column names. So the syntax of this function allows us to take the factor of a data set of this variable status. So we're looking at this cancer status. It's either 1, 2, or 3. I'm saying I'm going to take this variable, the status from melanoma data set. There are 3 levels, 2, 1, and 3. And the labels are associated with alive, melanoma death, and non-melanoma death. So you might be wondering why this is in non-numerical order, why they decided to do 2, 1, 3. And this is because 2 is affiliated with alive, and they wanted alive to be, or it makes the most sense for alive to be viewed as the reference. And what the reference variable just means is if down the road, if you're looking for like odds ratios where you're comparing, like, you know, you will be in, like, your odds ratios will be in comparison to what could be considered as defaulted, or I guess more common or normal, I guess. So if I run this, you'll notice the table 1 now has the titles for each different types, each level, 1, 2, and 3. It now reads alive, melanoma death, and non-melanoma death, which is much more interpretable than 1, 2, and 3. But we still have some issues going on in the rows, which we can do very similarly with factor for sex. The same thing. We're going to change 1 and 0 to male and female. I'm going to run this, and then we're going to change 0 and 1 to absent and present for the variable ulcer. And we're saving that to the same variable. So this just, we're overwriting the old version of ulcer, and we're saving it to the new version of ulcer. So I'm going to run this as well. The thing that is kind of nice about this package is that it works really well with this, this function label. So let me show you what it's producing right now. So I'm going to comment this out really fast. So this is what it's outputting right now. It looks pretty good, except for these, you know, the row names really should be capitalized. It kind of looks a little silly for them to not be capitalized. And that's where this labeling function comes in. Generally for coding, I think most variable names are undercase. Just, I guess it depends on your naming practices, which is a whole other conversation, but I prefer to keep my variable names undercase, just a personal preference. But you can make a label for each one of them that will only, it will populate in the table, but won't override the variable name. So if I print melanoma over here, oops, I can spell melanoma. You'll notice the variable names are still in undercase, so it's easier to code models and things down the road. You can also do a very similar function with units, with years and millimeters for the age and thickness, the associated units. You can add a caption and footnote. So I'm going to show you what all that looks like. I'm going to add all of this in here. Ooh. So now I have a title for this basic stats. They call it a caption. I have a footnote down here. I can say, like, also known as Breslow thickness, this thickness variable, it's in millimeters. You can see that my units have populated, which the units also will not impact the variable names for coding down the road. You don't have to keep typing age, parenthesis, years, parenthesis, when you're referring to this down the road. So this looks pretty good. But it's a little bit annoying with all this other stuff you have to do, all the data management. So I wanted to talk about a different table 1 package, table ONE, which is from the package table 1. Well, let me stop. Does anybody have any questions? Does anybody want to? Can check the chat.
Yeah, I would like to ask, how did you make the program to assign the footnote to the thickness? I can't see that anywhere.
Yes, so I think the footnote here, I think we typed it in. I don't know if you can see it. There is a very tiny A copied and pasted into the footnote here. I'm actually unsure how it's populating here. Thickness.
Yeah, I can see the little a, but I don't know how you made it
I see.
assigned to thickness, not to ulceration, for instance.
Yeah.
But it's probably not important, just if you don't know.
Yeah, no, it's a good question. I just noticed that it's actually populating there. I'm unsure how it's doing that. I'm wondering,
The label has the little a, Grace.
The-
On line 52.
this?
Yeah, that has a
Oh,
little a.
yes. Yeah, you're right. I just couldn't see it.
Okay,
Yeah.
thank you. That makes
There's
sense.
a little
Thank you.
baby A here, and that's okay. Thank you, Lala. Yeah, so I'm gonna move on to table ONE, table one. The function here is called table one, and I do like this package because you can create a table one very quickly with, one line of code. You can compare this to, this is kind of annoying to type out. You have to remember some of the syntax and things. So this is pretty easy, and I kind of like to keep this in my back pocket for when you're on a meeting with somebody and they want, summary statistics of like all the variables in this data set, like really quickly. This is something that you can kind of quickly pull out. But it does also allow for fairly simple conversions of class variables. So for up in the table, the prior package, we had to manually change all of the levels of sex and ulcer and status with different lines of code for each one. A good thing about this package is that we can make a vector of all the variables that we want to keep continuous in this case. Time, status, treatment, all these ones I want to keep continuous, and all of these ones I want to keep categorical. We have status, treatment, on spiders, all these things that I'm not familiar with. And we can feed them into this function, create table one. We have vars and my vars. These vars are the ones that we want to keep continuous. I am calling my data in, and then I have factor vars. So this factor vars will make anything that's in this list and also that occurs in this data set, it will make it as a factor, which makes things pretty nice. So you'll see, we have 0, 1, 2 for the status. We have stage 1, 2, 3, 4. So it is a little bit nicer. It is, in my opinion, not as pretty. It's not hard to read, but it's definitely not like manuscript ready. The creators of the prior table one package, they did write this with the intention of having it be like a manuscript ready like output, which I don't think is the case for table ONE. So I guess at different times or different places, but something to keep in mind. And they do have some options, like it works with this print function pretty nicely. You can, so for this like show all levels, you can edit a little bit. For example, you'll notice that like sex has 2 levels, male and female, whereas before it was only printing 1. And the idea here is if there's 2 levels, and you can assume that if it's 90% female, it's 10% male. And you don't really need to be printing 2 lines for each variable if you don't need to, but sometimes you like to have it explicitly written out, which I kind of like, but and they do have other functions. And if you're ever, a good thing to keep just in general for any package, if you're ever confused on the syntax of it, you can type question mark and you can type the function name. So I'm going to do create table one, and it will pull up the information about all these different things you can change. So create table one, vars, strata. So I can add tests here if I wanted to, and if I'm unsure like what include NA means, then I can scroll down and look at, I can find it somewhere in here. Yes. And it will tell you like if it's true, then NA is handled as a regular factor rather than missing. NA is shown as the last factor, all these different. So if you're ever looking at a function and you're not sure what's going on, this is a good thing to keep in your back pocket. And also another tips and trick things, I guess, if you press comma and you hit tab, this will populate some of the other calls that you can input when in whatever function you're using. So for example, like I can change the number of digits. So if I want to have 4 digits in this table, then I can edit it. And now all my variables will have 4 digits no matter what. So for the continuous variables. that is that table. My personal favorite is gtsummary, and I like it because it's very malleable. It is maybe a little bit confusing, and we'll talk about that in a bit, but I'm again going to quickly just load the gtsummary package, and then the table underscore summary is their tabling package. I'm going to run this with this another toy data set trial. And this looks pretty good. I think it looks better than the prior package, and it does a pretty good job. This, I mean, the data set was probably a bit cleaner, but it is pretty easy to read, and it, you know, has a nice footnote automatically populated and all these things. But the thing that I think is really nice about gtsummary is it has all of these functions you can add. So I'm going to go through some of these so you guys can kind of have an idea of what's going on, how powerful gtsummary is. So previously I'd only put in the data set name and the function. I can add, I'm gonna like this, I can add a by variable, which just means it will stratify the columns, maybe, yes, from drug A and drug B. It'll make 2 columns so I can compare between the 2 medications. If I wanted to add missingness, there are several calls here. I have it listed as if any, so I'm going to run this. And it will show you if there is any missing data. So for example, looks like there's 7 people with an unknown age for drug A and 4 with an unknown age for drug B. And if you're curious about the other levels, I think it's always and then never and then if any. Yeah, I believe it's always if any and then never. You also can change the text. So some maybe unknown is not a properly is not really an appropriate name for the missing data. Maybe it's more, maybe you'd prefer the word missing. You can change the row names from unknown to missing like this. If you think that there's a variable, like in this case, they think, you know, maybe grade is a little bit vague and you want to make it say tumor grade, you can actually go through and add, you can change the label with this syntax with the tilde again. So this is saying the old variable grade, I want to change to be labeled as tumor grade. So now if I run this, it will now say tumor grade. And you can do this with many variables in one step. So if I wanted to rename age as, I don't know, something else, or like year or something, I don't know, you could make a vector, like I believe like this, and then add more labels for each of your variables if you felt like that was appropriate. This is where I think gtsummary really stands out, is this statistic call. So you can change which variables are presenting which statistics. Fairly simple. The syntax is a little bit annoying, but once you get the hang of it, and I can show you what it's talking about, you can change what types of variables are presented. So in this case, this is saying for age, I want to present the median rather than the mean, and I want to present the 25th quartile and the 75th quartile. But for marker, I want to present mean and standard deviation, which are different. And then for the rest of the categorical variables, I want to do a little n over the big column n. So you take a look at the table now. I'm going to run this, and you can mess with these strings, and it's, you know, now you'll notice I have 28 over 98, and I have like ratios rather than percentages. So this is where if you have like very specific criterion for your table 1 or want it to be presented in a certain way, I feel like this is where gtsummary really shines. And if they have pretty good documentation too in their package about they have like some defaults with all continuous. You can set all continuous variables a certain way. You can set all categorical variables a certain way. You can separate some variables out. They have some more robust, yes, they have, you know, the little n is associated with frequency. They have median and these curly brackets. You can really make this table one, or like what's presented for each variable, very tailored to your project at hand, which is something that I think a lot of the other tables are lacking. The other thing, so I'm going to uncomment some of these rows. This is a very similar table. The other thing, so this first half is the same as this first half. I'm just going to continue going through some of these lines. You can add p-values. You can add an overall column. So I'm going to show you what some of this looks like. Computer is being kind of slow today. So we now have an overall column, which I always appreciate having, and I think is a good idea. You can have a p-value if you're trying to compare the age between drug A and drug B. Again, I would think about the interpretation of the p-value. But I just think it's a very powerful package. You can add like an FDR, you can control for multiple comparisons with FDR. And these, I don't know if anybody's familiar with tidyverse, but these are called pipes. And I have a little demo at the very end if anybody would like to see about the differences between tidyverse, which uses these pipes, and base R. And you know, you can add headers, you can bold certain labels, italicize certain levels, can modify captions. So it's a very malleable package. Go from there. And I see a chat about Arsenal. I know, I do know that the Arsenal package is also very powerful. I have not used it personally. I know a lot of my collaborators or a lot of my coworkers have used it before. I personally like gtsummary for its capability of how malleable it is, which I could be wrong with Arsenal. I'm not as familiar with it, but I'm not quite sure Arsenal has that same capability. I'm not 100% sure on that. Yeah, so someone asked in the chat, do you specify the test where p-value is derived, like chi-squared versus Fisher's exact? So I have a couple thoughts here. And it's always, in my opinion, good to double check it just to see if there's anything strange going on, but it will put footnotes in. So it will tell you like, you know, footnote 2, they ran the Wilcoxon rank sum test and Pearson's chi-square test for each variables. And it will tell you, it has like a flow, I guess, depending on the assumptions that are met. So I believe it's normal, if it's continuous and normal, it'll do t-test, and if it's not normal, it'll do Wilcoxon, and if there's a rule of thumb for Fisher's exact, that will versus chi-squared, and all those are defaulted. And I think there is a way, if for some reason you wanted to, if you didn't think that those assumptions were correct, I think there is a way you can change the p-value. You can edit whatever test is being used. But yeah, it's pretty nice to do quick. I would still double check it because I don't like to go blindly, but I think it is pretty nice to have that built in. And I still think I saw another chat come in, but I lost the chat box.
There's one question about if there's any functions that you can use to output the table to a Word document.
Yes, so that's actually a good point. And I'm going to talk about that shortly, actually. So some of these packages don't play well with Microsoft Word. So if you're familiar with R Markdown, you can output to HTML, you can output to PDF, and you can output to Word. Pretty much any package will play well with HTML. HTML is always the safest bet. And then PDF, I think, is followed shortly behind. And then Microsoft Word sometimes does not play well with tabling packages. One of the other reasons that I really do like gtsummary is that it plays well with flextable, and flextable, you can output anything to Microsoft Word. And I know table 1 is you can't convert to a flex table, and I know sometimes weird things happen with like runoff of like if you have too many columns, it will like run off the page in Word and it gets kind of goofy. So if you're outputting to Microsoft Word, I would highly recommend the pairing gtsummary and flextable together, or at least working with flextable if you can. And that's almost the only reason why I included flextable in this presentation, and I'll get to that in a minute. But essentially flextable is, I could argue, is not a table 1 package, but it is super powerful in terms of tabling in general. And it is important if you want to output your gtsummary table to Microsoft Word. So I kind of left it in here for you guys. Yes, and then I think that was all the questions for now. And yeah, the other thing that I like about gtsummary, you can see my bias is showing, is it has some like themes. So you don't have to, try to edit visually too intensely. I guess it didn't really change much, but there are default themes you can change that can change the like appearance of it. So if you want to search theme gtsummary, there's compact if you want to make it really tiny. There's like different journals that have like themes here that would maybe make your life easier. Different journals have different like publishing expectations. They have all these different themes that might make your life easier. Kind of if you want to have if you like a certain theme and find it pretty, you can just have a 1-line call. And then some of these themes, like I have a note here about these themes, can be applied to more than visual aspects, and you can see how certain variables are displayed. So you can set the theme of how the mean and standard deviation are displayed. So I can like run this, and I believe this changes. Yeah, now I've changed the mean and standard deviation to look like this. If I wanted, so there are a lot of themes. It's very malleable, but it can get a little confusing because there's so many options. I feel like you can get kind of lost in the sauce, if you could say. Like here's a different theme, just different, like it sets the rows up differently and stuff. So it's pretty powerful in that sense. But yeah, anyways, the Microsoft Word question was a good transition to flextable, because flextable, unlike the first 3 packages I talked about, the first 3, or I guess really the first 2, really are only used for table 1. gtsummary also has, which I guess is a note here, gtsummary also has these other packages or functions in that package called table regression and table UV regression, which if you get to a point where you're fitting models, it has a very similar syntax to fitting results from models, which this is not the purpose of this talk, but if you fit like a linear regression or something, they have functions that will make it into a semi-pretty table pretty quickly. So if you're trying to put your estimates and your p-values into a table fairly quickly, that's a good way to do that. So I guess just more of an FYI. Yes, so flextable, unlike the previous 3 that make a certain type of table, flextable is really makes anything into a table that plays well with Microsoft Word. So if you wanted to convert a data frame or a CSV into a table, flextable can do that. So you can kind of think of flextable as more of a class of table more than like a tabling package. So what I'm going to do is I'm going to load the flextable package, and this is saying it's loading extra stuff in the back, which is totally fine. I have this other toy data set that comes with it. I'm going to load it in. I'm going to show you what it looks like. It looks like this. Got some ozone and wind, some weather things. And again, I can edit the flex table with some of these functions, and they have themes. I'm going to show it again. Now I have a top row. I can add a footer like this. Now I have an air footer, or a footer like that talks about daily air quality. I think I can add color, but sometimes this doesn't work. Yeah, I feel like the default changed it, but I can add a caption. now I have a title going on here. And they also have different themes. So if I wanted things to be boxed instead of across rows, you can do that with different themes. And I can even change like the default settings. Like I wanted the font like really little or the background gray, I could do that. If I want to make the font size like 5, I could do that. And this is where this autofit call is super helpful when outputting to Microsoft Word, because what this autofit does is if you're knitting it to Microsoft Word, it will autofit the width of it to fit within the however many inches the page is. So in my experience, what happens oftentimes with outputting tables to Microsoft Word is the tables are too wide, and then you end up missing like the right hand side of your table, and then you get annoyed and you whatever. So this autofit function is amazing when outputting to Microsoft Word, because you ensure all your data is there, which we love. Yeah, and I have a note here. Note that flextable plays well with gtsummary with the function as flextable. So if I output a gtsummary object and I save it, my table 1 as like table 1 gtsummary or something, I can change it to a flex table by just using the function as flex table. And and the reason why I wanted to include this is because you can match the themes across your entire report for a more cohesive look. Yeah, and I know that some packages don't play with all 3 outputs. So this is kind of talking about exactly that. Flex table is one of the friendliest outputs for Microsoft Word. And similar to flex table, we have Kable, and I think Kable in my head is kind of like the HTML version of flex table, where it is not a table 1 packaging per se, but if you for some reason were to create your own table 1 or create your own data frame and I want to make it look nice, this would be the package you use. So again, I'm loading this Kable extra package. It's going to load a couple other things in mask of another function that must be a duplicate. So empty cars is a pretty common R data set that appears a lot. So the default Kable just makes it look a little bit nicer rather than just printing. It changes like the font so it's a bit easier to read and spaces it out kind of nice. So it's a really easy way to change, I guess, make a simple data frame like look kind of nice. And you have a lot of options here. You can change the digit numbers, you can you can like add a label and add it here. I think my labels must not be outputting. Oh, good. Maybe I have to knit it, but yeah, and here I have, yeah, you can change the column names. So if you remember in table 1, in the earlier functions, we had to manually change the labels of each of these variables. If you wanted to change all the labels all in one go, and you're working with Kable, then you can simply do that like this. We need 5 names here, and you can add, this is the title of my table. And you can do it all pretty easily in one big line of code, essentially. Yeah, and then there's an additional package. Oh, I don't know if anybody is familiar with Unix coding, but if you wanted to, for example, Iris has column names, has column names with periods in the name. So if you're familiar with Unix coding and you know how to use G substitution, you can easily replace the periods with spaces. So I don't know if anybody has background in that, but it plays really well with Unix coding if you have background in that. Not necessary by any means, but and Kable has an additional, like a sister package. You can think about it as a Kable extra, which has again a bunch of styling options for the package. So if you're thinking about making something ready for manuscripts or trying to make it more legible, or maybe someone want to highlight a certain row, and this oh, I see a question in the chat about how can you explain what the knitter : Kable syntax? Yes, good question. So yeah, so if I load a package in, like if I was gonna load like this and go Kable, this will, oops, I can spell library. This will load everything in the Kable extra package. If I didn't want to load the entire package, I could do Kable extra : and only call the one function from that package without loading everything else. In a scenario where this may be nice is if there's ever a function that has a duplicate name. For example, if there are some fairly common function names, like I can't, like I don't know, say there is a mean function in one package and a mean function in package 2, and you knew you wanted package 1 for some reason, you could ensure you are using the correct function by doing, like, the name of package 1 : the function, function name, like this, and then you can use it as normal. So the : is just saying, like, I want this function from that package. It's just a way to ensure you're using the function you actually think you're using. So this is, I didn't have the knitter package loaded, or it's sometimes, talking about reproducibility, this is where you can come into contact with some issues too, is if I know of a Kable package that, or I know of a Kable function from the knitter package, but maybe there's another Kable function from a different package. It is arguably good practice to include the package in front of it with 2 colons, just to prevent things like that. 9 times out of 10, you won't have that issue, because I don't think there are too many package names that overlap that specifically, especially if you're only loading in packages somewhat diligently. But yeah, I guess the short answer is it's the package that function comes from.
Yeah, that's great. Thank you very much. Thank you.
Yeah, of course. Yeah, and then Kable Extra is kind of the sister package to Kable. It talks a lot about formatting. You can change the font size. You can, and this is what's helpful too. Maybe you want to highlight a certain column. You can, you can change the color. You can highlight, rows 2 and 3. You can highlight row 4. All these different rows. You can make it italicized. You can make it bold. You can, if you wanted to angle your text for some reason, I don't know why anybody would want to do that really, but it's a pretty powerful in that sense. If there was something in particular that you were trying to highlight in your table, which is kind of nice. And then same thing here, if you wanted to add and I know this is kind of weird, like the overarching column names is sometimes hard to make. Like if you want to do we have 2 different length and width or whatever, you can have measurements and attributes. Like you'd have the 2 different levels of column names, which is kind of not every package can do. So this is another way you can add however many headers above that kind of display the different, if you wanted to kind of do specific headers and then semi-specific headers and then general headers, you kind of wanted to back up a bit. But yeah, and I know we have 5 minutes left, so super quickly, well, I guess, does anybody have any questions? If we have time, then I will go over base R versus dplyr, but if not, then I will continue. Any questions? Okay, super quick, I'm going to go over base R versus dplyr, and you'll hear these 2 things a lot. I think dplyr is very common these days. It didn't used to be that way. I think maybe, I don't know how long ago, a couple of years ago, 5 years ago, dplyr was fairly new. They can do equal things. Pretty much anything you can do in dplyr, you can also do in base R. Base R just was the way that R was created, and dplyr kind of came later. So the idea is that R was how it was created, base R is how it was, created, and then dplyr and tidyverse is a bit easier to read. So I have a couple examples, and I'm working with this mtcars data set again. So if I wanted to order this data frame in order of miles per gallon, this is all over the place. this is how I would do it in base R. And this is kind of ugly syntax. Like this is a little, it's not friendly to the eye. And what this is saying is, you know, this column, this box means that I am indexing this data frame before the comma. You're looking at rows rather than columns. So I am ordering the row empty cars based on this miles per gallon variable. And it's not very easy to read because you're kind of working from inside out, and it's kind of, there's not a lot of additional words to help it with. So I'm going to run this. The equivalent of this is dplyr, where you would say, okay, I'm starting with this data set empty cars. Then I'm going to arrange it in terms of this variable. So it's much easier to read, which, you know, part of reproducibility is being able to give your code to somebody else and have them kind of get a gist of what you're doing without running anything. And this, in my opinion, is much easier to figure out what's going on than this. So I'm going to run this too. And I have this function all equal that just checks to see if the outcome is entirely equal. And you can see that it's doing the same exact thing, like the remaining variables, like base our example order, like now we have this in increasing order from 10 to 33. It does the same exact thing, but this is so much easier to read. If you get into whole big data analysis, this is probably like milliseconds faster, but if you're willing to compromise some speed, this is much easier to read. And same thing with this. I have a very similar example, but with filtering. If I wanted to keep cars with a cylinder of equal to 8, can do the same exact thing. Very similar syntax. You know, you can start with, I'm starting with this data set and I'm keeping everything with a cylinder of equal to 8, which is much easier to read in my opinion. And you can see that they're equal again. And the reason why I wanted to mention this in this presentation with table ones is because a lot of these packages play very well with dplyr or tidyverse world, which means if I start with, you know, you can combine a lot of these steps. You can start with this data frame, you can pipe it and say, okay, I'm going to start with empty cars. I'm going to keep only those of the cylinder of 8. I'm going to arrange it according to miles per gallon, and then I'm going to make it into a pretty table. So you can do a lot of this stuff in one step if you are comfortable with piping, whereas this, even these 4 lines, you would have to do, I tried to do it in base R and I got annoyed and I quit. So if that means anything. But I know we have 2 minutes left, so I'm going to stop sharing my screen really quickly. Oh, I guess I do have a quick table, but I kind of did go over it. It is kind of just displays what we talked about. We have the different packages on the left and then kind of what I've gone over. So we have some packages that are kind of prettier, easier syntax. Syntax can be simple, but it's probably a bit more confusing depending on you know, how many options you want to do. So, and this is all uploaded in that. So if you want to spend some time and look at this, I don't want to keep you late because I know it's late, but yeah. And I think Lala just sent an attendance and raffle thing in the chat. So please take a look at that and fill it out and enter the raffle to get your AirPods or whatever is going on. But yeah, other than that, I think that was all I had for you guys. Does anybody else have any questions before we wrap up?
Just a quick announcement. We are recording all of our lectures this week. So if you're interested in watching them after this week, please follow us on LinkedIn or Twitter, and we'll be posting the links to our YouTube channel once those are up. Otherwise, don't forget to sign the attendance. You could win an iPad. It'd be fun. Thank you, Grace, so much for presenting today. I really appreciate it.
Yes, of course. Thanks, Lala. Thank you, everybody, for showing up. I appreciate it. I know it's late. Okay, well.
Thank you. Bye.
Bye, everybody.